Hello, Jeff Disher here again. Today I'm going to do something that's kind of just a laid-back sort of fun idea, which is talking about some of the humorous bug names that you'll sometimes hear developers use when talking about things. Now, generally speaking, most of these things are not terms that developers commonly use, but they're kind of cute ways of describing them, and sometimes you do actually hear people describe them in these ways. So I'm going to be going through just four basic bug names and kind of describing their origins and what they mean and how you debug them. It's going to be Heisenbug. There's a Bohrbug, Mandelbug, and Schrödinbug. So first of all, the Heisenbug. Now this is one you probably will actually hear people refer to from time to time because it is descriptive and it does communicate what you mean. So this is named after Werner Heisenberg. He observed that when you're trying to observe something in a system, you actually end up altering it. This is just because of the way that you need to observe something, to measure a particle or something, you usually have to interact with it in some way. That interaction is what alters it. So this comes up in software as well in certain situations. This refers to a situation where a bug will disappear when you're trying to actually debug it. Or, alternatively, when you're trying to debug something, you'll find a new bug on your way to it, which you normally didn't see while running. Usually, these things are timing related. If you have something like a multi-threaded or asynchronous algorithm, those things end up being very sensitive to perturbations in timing because certain things have to happen kind of relative to each other, but the order is not well defined anymore. So any kind of change to the timing can cause a certain bug to occur. Debugging will almost invariably change the timing semantics of what you're doing. Historically, it could also be caused by the debugger itself. Sometimes what the debugger would do when it was interacting with a piece of software is it would actually change what it was doing. This is pretty uncommon nowadays, but it used to be an issue in some kind of less common operating systems and environments. Usually now it's just timing related. So these end up being difficult to debug because by definition you pretty much can't debug them. Usually, even doing simple things like trying to add more instrumentation or logging to try and understand what's going on around the time the bug occurs, those things also change the timing dynamic of the system, so it's not going to get you away from this. You're still going to be touching this. Now it might be, depending on the sensitivity, that might help you out, but you're still looking at a problem that can be shaped by that. So you sometimes use some kind of exotic techniques for this. This often means you have to do something like instead of collecting information prior to the bug occurring, you might have to do something like just try and detect the bug as quickly as possible and log as much, or kind of capture enough of the information of what was going on in the system at the time right after the bug happened, so you can do sort of a post-mortem breakdown to figure out, okay, based on what was happening when we observed the bug, what could have caused this. So these end up being pretty common because they come up in a lot of asynchronous or multi-threaded environments, and they are hard to debug. So you see this a lot. Now, Bohrbug you don't really see, it's not a term anyone actually uses. I think it's just added here for completeness when I was looking through some of these terms. So this is named after Niels Bohr, a name which I'm probably mispronouncing, where he was talking about discrete electron energy levels. What this means is that around an atom, the electrons all are at a specific energy level. You can either be at X or Y, not in between them. It's kind of digital in that sense, we'll say. This meant that what this refers to in software is the idea that a bug is recreatable under well-defined conditions. Now, this doesn't mean that you know what those are. This ends up ultimately applying to many kinds of bugs because once you understand how they're kind of the circumstances of their occurrence, you can usually recreate that and observe the bug. This is often how you verify that a bug's been solved. So most bugs, kind of once all is said and done, once you get them really down to their core, they end up being a Bohrbug. So if you find something that, once you've defined that condition, whatever the well-defined conditions where the bug occurs are, this ends up being easy to debug, easy to resolve, easy to verify that you've solved as well. Because you can often then communicate to other developers you're working with exactly how to identify this problem, so they can avoid doing duplicated work on duplicate bugs that show up elsewhere. So a Mandelbug, this is also a term that you don't really hear anyone use. It seems to be, again, more added for completeness here. But it's named after Benoit Mandelbrot. He developed the areas of kind of chaos mathematics and fractal geometry. So if you've ever seen like a Mandelbrot set fractal, it's named after him. This refers to the kind of bug that whose underlying cause is so obscure that the behavior of the bug just seems chaotic. Usually this means that the cause of the bug itself is very far away from where you observe the bug. Its actual manifestation is further on. Because really when you're looking at bugs in software, you're only looking at symptoms, you're not looking at the problem. So this kind of bug can come up where you might have something like, say, a very large data set, which is being kind of transformed over time by the algorithm. And this could be running for perhaps months. And a Mandelbug would show up in this situation as being one of the changes to the data set was incorrect, but it didn't notice that it was incorrect. It just kind of poisoned the data. Over time, as the algorithm continues to run, the poison will end up spreading. And what you end up seeing then is all kinds of very weird bugs that seem completely unrelated to where the actual bug was, because you're only looking at where that poison has sort of breached the surface elsewhere and caused other parts of the algorithm to fail in ways which were more understandable. Usually things like this are usually very hard to debug because what you're looking at is not the problem. Usually where the crash or the bug occurs is not where there's actually any problem going on. Usually the actual error is somewhere very different. So it's hard to debug these. You can kind of mitigate them a bit by applying some very kind of rigid interpretations of algorithm correctness while you're writing this. Often things like, for example, writing a lot of assertion statements into the software to force it to crash early as soon as something goes wrong. That's kind of your best defense against bugs like this because they're very hard to find and they can be very damaging because that data set now is completely invalid. Hopefully it wasn't important. A Schrödinbug is another one that you sometimes hear people refer to this, but it's not things that people will use by name a lot. It's more just an interesting way of observing what the bug means. So this is named after Erwin Schrödinger. So this is related to his famous thought experiment, Schrödinger's cat. The idea that when you have this cat in this box with this poison and other things like that are related to it, you don't know if the cat's alive or dead until you open the box. Meaning that he argued it's actually both. So and this has interesting implications. It comes up in other areas of science as well. And there's an interesting kind of logical argument behind the thought experiment, which is very interesting. So what this refers to in software is a bug that is actually very long-lived. It's been in the software for a very long time. And everything just seems fine until one day there's suddenly a slightly new use case that's applied to the software and the bug occurs. And as the kind of story goes along with this bug is that typically that also means that now the bug shows up all the time for some reason, just because you've observed it once. And this happens a lot just in old software, and it's not because there's anything wrong with the old software or because we do things better now, far from the case. It's just that for whatever reason, a certain kind of code path through the software or a certain permutation of pieces of information were not used historically, and they're suddenly being used now. And they expose a corner case that was not formally understood. And there's a bug in that corner case. So this turns out to be a case where the software itself never actually worked, which is usually kind of the strange thing about this, is that it'll show up in software that no one's even touched for years, perhaps. And it ends up being really surprising because everyone thought that it worked, nothing weird had happened. So these happen a lot, and they always will, just because of the nature of that's how the possibilities of software work. Unless you really, really restrict what you can possibly do in the software, you will always see something like this come up. And the ways to mitigate it basically have to do with things like, well, make sure you're testing things well, make sure that your software itself is very restrictive to how it can be used. But generally, this is something that's always going to be coming up. No matter what you do, there's always the possibility for a Schrödinbug coming out of the woodwork at any random time in the future. So anyway, I hope that was informative. Most of those, like I said, are not terms that software developers actually use very often, but they're kind of cute, and usually you get kind of a chuckle when someone points out that, oh, that's this kind of bug, and like, oh yeah, I get it, that makes sense. So it's kind of fun, but and more just kind of a cute realization that you can make, but nothing too critical or something that comes up too often in the actual language used. So if you have any questions, post comments here, or contact me at my email address here. Or, of course, if you wanted to suggest a talk of a different, like any kind of specific talk you had in mind, send me an email here and I'll put something together. Thanks.